I came from Vancouver, Canada, to present a little toy program, which is basically a clone of Ping, and I'm sure everybody knows what Ping is. Does anybody not know what Ping is? Oh, it's one person. So this clone of Ping has very few features. Basically, I'm only interested in sending echo requests and getting the echo response. So I've limited it to only IP version 4. And as I've mentioned that, you can actually tell it to send a maximum number of count of echo requests. And there's no support for changing the payload of the ICMP packet. And if you've used Ping before, it has like tons and tons of features, like you can control path MTU discovery, you can set the TTL on the IP packet. So I'm just going to not do any of those, just to make it simple. So I've chosen a constant for the payload, in this case a quote from the Stoic philosopher Epictetus. This quote was chosen carefully because the length of that is 56. So because that's basically the default size in Ping. So I spent quite a lot of time just trying to find it. It's quite cool. Because I want to get it to be like exactly like Ping, right? So here's just a sample output from Ping. One thing to highlight here is obviously you can see that the peer media router FP2, and then there's also ATS V2 FP in the header. So this is all pretty standard. So this is goping. There's a couple of differences. One thing is that the DNS names have a dot at the end. It's mainly because that's what the Go API returns. So I could actually remove that. Other than that, it's mostly the same. There's obviously one difference here is that there is no TTL in the ICMP responses. That's because I haven't gotten around to parsing the request headers, which is where the TTL is. So the response headers. And so let's go forward. So just a little bit review of the ICMP packets. So you basically have the IP header. So the ICMP packet is the payload inside an IP packet. The IP header has 20 bytes, usually, for IPv4. And then for the payload, the ICMP header is 8 bytes. And then the data can be a variable length. And then in the ICMP header, there's basically two fields, the type and the code. For IPv4, for the request is 8, and the code is 0. And then for the reply, type is 0 and code is 0. So there's many, many types of, you can think of ICMP as an error delivery mechanism of the IP protocol. So ICMP requests and response are just and so I'm using the ICMP package that's provided in the Golang library. So you can see here, if you want to create the message for the ICMP packets, it's pretty simple. And then, so down here you can, in the second diagram, you can see that you have the constants for the ICMP types. There's others, for example, the ICMP time exceeded code as well, which is returned to you when the TTL goes to 0. So now the rendering part. So as you can, so my goal is to get it as much high fidelity with the ping output. So in this case, when you ping Usenix, fe4.h.pantheon.io. So that's basically, from my experiment, is the C name, the canonical name of usenix.org. And then in the echo response, first you would print the peer address, and then you put the resolve IP address in brackets. So some lessons learned is that so if you use net.lookup IP or net.lookup host, it basically does IPv4 and IPv6 resolution. All right, so it returns you a slice of IPv4 and IPv6 addresses. So you need to, so in my case, I had to be careful, and I'm only interested in IPv4 addresses. So lookup CNAME is the function that basically allows you to get to basically crawl through the CNAME for the usenix.org. And then at the end of the ping output, there is you need to basically print all the statistics about the round trip times. So basically, I should mention firstly about how round trip time is implemented in ping, in the original ping. They basically, when you send an echo request, you actually put the timestamp, the current time of in the payload, right? And then, so you send that out, and when you get the request back, you would, so the standard says that it will basically return you the actual payload. Then you would read that timestamp and subtract it from the current time. So in my case, I was a bit lazy. I just take like a timestamp before I sent it off, and then when I receive it, I just subtract it out from the current time. So probably going to change that. Now for the so basically, I also wanted to calculate the sample variance of the time series of round trip times that I've collected. So the formula that you see up there is the mathematical formula to calculate variance. But I've learned from this guy, John D. Cook. He basically introduced us an old method from 1962 by B.P. Welford, which basically provides you the correct answer. So if you use this formula right here, which is which is taught in statistics, sometimes you may get like a negative variance, which doesn't happen. Okay, so I wrote a little package here, the stats package, which is an implementation of that method. And onto raw sockets. So in order to be able to craft your own IP packets, we need to use raw sockets. And one of the rules about the raw sockets is about using raw sockets is that you need to be able to be either root in the old school way, or you can use the capability feature of Linux. And this dovetails nicely with tests, the first presentation from tests. So basically the code will check, are you root, which is the identity part, and then so you can use the Linux capability to, in the in the screenshot below there. So you basically give it just a minimum number of capabilities just to use raw sockets, right? And then it will work. Now, if you don't do it, you'll get an operation not permitted error. And just for your information, ping, I mean, on my VM is basically currently still set UID to root. So just a little interlude. How much time do I have? So another feature that I was also experimenting with was sending ping on machine with multiple network interfaces. So basically what I had to do was, in the original ping, you have a -I argument option in which you give it the interface name or the IP address. In my case, I decided just to accept the interface names. And so here, this is a demonstration of goping, in which you send it out through ETH0. And so what I do is basically I just enumerate all the interfaces on the operating system, and then send back a map of interfaces, and then with the IP addresses. So this seems to work, and if you don't trust me, I'm going to post a screencast of it, or you can just download the application and try it. And one last thing, so this one also supports, I just added a feature that allows you to ping domains that are encoded in Punycode. So basically, any domains that has like Unicode characters in them. So this is an example. And I'm using the internationalized domain name package to do this. So this is some weird behavior when I was testing this out. I didn't know this before, but you can actually ping the address 0, and it would resolve to localhost. So I tried it with my goping, and it failed. Then you change the resolver to cgo resolver, and then seems to work, but still a bit weird because I'm getting 100% packet loss here, right here. I think there's a bug in there somewhere. And I also learned that if you put in like a partial IP, like address, like 1.1, it will actually resolve to 1.0.0, 1.0.0.1. You can try that yourself. It doesn't work on goping, but change the resolver and it works. So that's nice. And that's all. Thank you.